Hello, once again. Good morning, good afternoon, good evening, whatever be it. Okay, I hope you are safe. Everything's fine. Be safe, be joyful, and keep smiles. Be safe and be joyful. Okay, we'll continue with our discussion in the chapter motion. In this, and now we have moved on to lecture 3. Previously, what we have discussed is, in the first lecture we discussed about rest, motion, and the fact that these two terms are relative. In the second class we discussed about different types of motion, and they can be broadly classified into 7 types of motion. What are those? Translatory, rotatory, circulation, oscillatory, vibratory, periodic, and non-periodic. And then after that we started discussing each motion in detail. And what we had discussed is what do we mean by translatory motion and rotatory motion. If the body moves along a straight line or curved line such that every point on the body covers the same distance in same interval of time is called translatory motion. Rotatory was important. Rotatory means body rotates in such a way that it rotates about a fixed axis. It has to rotate about a fixed axis or a fixed point, and this point is present inside the body. Now what we will discuss today is, we will talk about circulatory motion, circular motion, oscillatory motion, and vibratory motion. We will try to discuss these 3 types of motion in today's class. Chaliye, let's start. Okay, we'll start with circular motion. Now, what do we actually mean by a circular motion? Let's first go through the definition. When the body moves in a circular path, then the motion is said to be circular motion. It's very easy to understand. Suppose this is you and this is a circular track, and if a person begins to run on this circular track, then we say this person is undergoing a circular motion. If the person begins to move in a circular path, what is this? This is a circular path. If any object or body begins to move in a circular path, it is called a circular motion. Now see, the circular motion happens about a fixed point. This is the fixed point. Just a minute. I need to point this out. Please note this, that the circular motion happens about a fixed point or axis present outside the body. कुछ याद आया? Outside the body. Whereas in rotatory motion, the body rotates about a fixed point or axis which is present inside the body. Do you get the point? In rotatory motion, it also moves in a rotation only, but it moves about an axis which is present inside the body, whereas a body moves about a fixed point or axis which is present outside the body. This is the body, but the axis is, this is the fixed point. Is it clear? I hope it's clear. Fine. Now we'll go through some examples. Let's go through examples. What what we'll do is we'll go through examples. Fine. So we'll just go through the examples. First example is the motion of a car along a circular path. If over here we have a car and this car happens to move in a circular path, then we say the body is under a circular, the car is under a circular motion. The motion of a car along a circular path. Next, the motion of a hands of a clock. We all have seen these kind of clock. Now this, the hands of the clock will move how much? Like this. That is, they are moving in a circular path. The motion of satellite around the earth. If this is our earth, then the satellite moves around. If this is the satellite, then this moves around the earth in a circular orbit. The whirling of string with stone tied to one end. We all must have done this in some time or the other. What we do is actually we'll tie a string to one end and then we'll start rotating like this. I don't have any objects to show. No, I don't have. It's simple. You just take any object, you tie it to one end, then you just play it like this. We all have done it some time or the other. This is example. Okay? And I just left some space over here to note that first thing, that a body moves about a fixed point which is present outside the body. And the second point is, see, the distance of this body from the fixed point is always constant, and that is called the radius of circle. Do you remember this? If the object moves here, the distance between the center, the fixed point, and the body is r. If the body happens to be over here, in that case, the distance between the body and the center, will be how much? If it is r over here, it has to be r over here, because the distance between any point on the circumference and center is always same, which is called the radius. This is the second point. The distance of the body from fixed point is always the same, for circular motion. I hope it's clear. What is circular motion? If the body moves in a circular path about a fixed point which is present outside the body, is called circular motion. This fixed point about which the body rotates has to be outside the body, and the distance of the body from the fixed point is always same, which is called the radius of a circle. And here we have few examples. I hope it's clear. Chalo, we'll make next. Okay, chaliye dekhiye now. Now I just want to know whether you all understand the difference between rotation and revolution or not. What is the meaning of rotation and revolution? Just try to, if you know, it's good. If you don't know, just try to understand. By the word rotation, we mean the movement of the body about its own axis. Ji haan. The movement of the body about its own axis. Let's go to the example which we did last day. Whereas revolution means the movement of a body about a fixed point or an axis which is present outside the body. Just try to understand. If this is the book, if this book begins to move in this fashion. यहाँ पे क्या हो रहा है? The body is rotating about a fixed axis which passes through the body. Is it fine? The body is rotating about a fixed axis which passes through the point which is present inside the book. But the same book can go like this also. Now please try to understand. Is it too big or what? See. Now what is it actually doing is it is undergoing revolution. It is undergoing revolution. The same book is moving about a fixed axis which is somewhat over here, such that its distance, is it clear? Like this rotation. If it moves like this, revolution. Let's just go through the definition. Rotation: the motion of a body about its own fixed axis present inside the body. Present inside the body is called rotation. The motion about a fixed axis present inside the body. Whereas, what do we mean by revolution? The motion of a body about a fixed axis present outside the body. Revolution means, if this is pen, if it begins to rotate like this, it is called rotation. But same pen, if it begins to move like this is called revolution, because now it is moving in such a way about a fixed axis like this. So this brings us to the question that what is the difference between circular motion and rotatory motion? Just like the same way where we discussed what is the difference between translatory motion and rotatory motion. In translatory motion, every point on the object covers the same distance in same interval of time. Whereas in rotatory motion, the points closer to the fixed axis covers less distance compared to the point at a far distance from the fixed point. I mean, each point does not cover equal distance in equal interval of time. Now let's see the difference over here. The difference is that in rotatory motion, the fixed axis passes through the point inside the body, whereas in circular motion, the fixed axis passes of revolution lies outside the body. That's very simple. Let's take this example only. Suppose this is a book and this book is rotating in this manner, In this case, the axis will pass through this. This is the axis of rotation. Fine. But on the other hand, if a particle over here is undergoing circular motion, then for this point, the fixed axis will be somewhat over here, which is present outside the body. That's it. We'll move on to the next slide. Is it clear? In case of rotation, the fixed axis is present inside the body. In case of circular motion, the fixed axis is present outside the body. This is my body. See, this is my body. Not my body, book. And this is the body over here. See. The fixed axis or the fixed point about which it is rotating is present inside the body. But this fixed point is present outside the body. It's very simple, Papa. Now we'll move on. Let's move on to the next slide. Okay, now we'll move on to the next two types of motion, which are oscillatory motion and vibratory motion. Now the idea is that we are trying to study these two motions together because they are almost similar with slight difference. We'll just point out the difference. Okay, first let's go through the definition. Okay, the to and fro, this word is very important. The to and fro motion of a body from its rest position or mean position. You can either call it a rest position or mean position. It's called oscillatory motion. the to and fro motion of a body from its rest position is called oscillatory motion. Now let's try to look over here. What is there in the definition of vibratory motion? Over here also we have the to and fro motion of a body from its rest position. Again we have the same term. Now the only difference is over here, with a part of the body always remaining fixed. With a part of the body always remaining fixed is called vibratory motion. Now I'll just try to give you an example. Please note it properly. I hope you all have, we'll just discuss about oscillatory motion first. I hope you have all seen, in Hindi what we call jhula. Swing. You all have seen a swing. How is it actually? If this is the rod, over here it's one end, over here it's one end, and over here you have a place to sit. It's tied over here. And over here you can just sit and go on. Now just try to understand. If this is the swing, initially the swing will be at rest. Fine. The position in which the swing is at rest is called the rest position or mean position. Is it clear? What do we mean by rest position or mean position? If the swing, this is the swing, if the swing is undisturbed, we have not even touched the swing. In that case, the swing will be at rest. And suppose this is the mean position. This point is the mean position. Mean position. Okay. This is the system, right? This is the mean position. Now, if I disturb it, when the string starts to move, how will it move? This is the mean position. It will go forward, then it will come to the mean position, then it will move in a backward direction. Then again it will go to the mean position, then again forward direction, then it will come back to its mean position, then again backward position. So what it does, it moves from forward to backward, passing through the mean position. Then how will it go? It will just move like this. This is the mean position. Again mean position. Again back. Again this. Again this. This. So the swing begins to move from forward to backward, forward to backward, forward to backward, forward to backward. This is called to and fro motion. To and fro motion. If I keep my hand over here, this is also to and fro motion. This is also kind of oscillation, because my hand is oscillating about the mean position. This is the mean position, forward, same position, backward, forward, backward, forward, backward, forward, backward, forward, backward, forward, backward, forward, backward, about the mean position. A kind of oscillation. Is it making any kind of sense to you all? First thing you need to understand is what do you mean by to and fro motion. A motion of this kind. Back, forth, 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 forward, backward, is called to and fro motion. And if the object is not exhibiting motion, it will remain at rest. The position at which it will remain at rest is called the rest position or mean position. I hope it's clear. Let's remove this. Now, when you come to this vibratory motion, over here also the particle will exhibit to and fro motion, to and fro motion, to and fro motion, to and fro motion, to and fro motion. But the condition is that a part of the body will always be fixed. The part of the body will always be fixed. Let me give you an example. Now let me give you an example. See, I hope you have seen a pendulum also. This is suppose a pendulum. This is a pendulum. Now if I just remove it like this, this is the rest position. If I take it to one end and move like this, then this is also kind of oscillatory motion. Means the pendulum of a bob shows oscillatory motion. It's going this, 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 this. Fine. But now suppose if this is the wire, if I've stretched it, this end and this end is fixed. This end and this end is fixed. Now if I just stretch it and release it, it will start vibrating like this. This is vibratory. Why vibratory? Even this is showing to and fro motion, but the ends of the wire or the body are always fixed. They are always fixed. I hope it's clear. Is it clear? If I just stretch it, if I just stretch it like this, if I just stretch it and I plug it in between, what will happen? It will start vibrating like this. It starts vibrating, fine. Oscillation is there, to and fro motion is there, but the two ends of the body are always fixed. They are always fixed. They are vibrating like this, doesn't matter. But the ends of the body are always fixed. This is the only difference between oscillatory motion and vibratory motion. In oscillatory motion, this is to and fro motion about the mean position, blah blah blah. Vibratory motion, to and fro motion about the mean position, but the part of the body is always fixed. Okay, let's move on to the examples. Finally, let's wrap up the video by just going through the examples. These two we have already discussed. The motion of the bob of a pendulum. Motion of the bob of the pendulum. And then motion of the swing. Now over here, the motion of the vocal cord when we speak and sing. Inside our tongue over here, what is actually there is that if this is your throat, I'm just giving a vivid explanation. This is your neck region. Then over here you have something like this. Slight gap is there. They're almost touched like this. When you speak, they begin to vibrate like this. This end is fixed. This end is fixed. This end is fixed. When you speak, the air pressure which generated starts flapping this vocal cords, and hence sound is produced. So this one end of the vocal cord is always fixed. Hence they execute vibratory motion. Over here, the neck region is controlled like this. So when you speak, they start flattering like this. Is it clear? The motion of the vocal cord. The motion of wire stretched at two ends. If this is two ends, this is the wire, it is fixed at both ends. If you just plug in the wire, it will start vibrating. And it will start vibrating like this. If a wire is plugged in, it comes to rest. The motion of membrane of tabla when played. Same for tabla also. If this is the tabla, when I strike on this, then membrane will start fluctuating like this. See, the end of the membrane are fixed to the tabla. The ends of the membrane are fixed to tabla. And they start. This is, suppose this portion is your membrane. If I start striking tap 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 tap, then the surface of this will start fluctuating like this, vibrating like this. And same is true for this, whether you have musical instruments like guitar, violin, sitar. The wires are stretched between two ends and you have a plug used. Vibratory motion. The ends of the wire are fixed. Is it clear? So I think we'll keep this much for today. Next, we'll move on. So thank you so much for watching. Have a great day ahead. Chalo. Good night.